Hi guys, so in today's video we are going to be tackling trigonometry. So trigonometry, obviously in grade 11 we're going to be adding a little more meat to what we already learnt in grade 10. So before we touch on the grade 11 work, I just want to revise a little bit of what trigonometry is because you will need to know it for the grade 11 work. Right, so trigonometry, we know the foundation is based on these three ratios, sine, cos and tan. Easy way to remember our three ratios obviously is SOHCAHTOA, and I'll get into the R and OR now, right? Very important is to also note that these three trig ratios only work in right-angled triangles. Right, very important to note. So sine, cos and tan only is limited to operating in right-angled triangles. So we also know that the base of these ratios are dependent on where the angle is. So if my angle is over here, then we know that this will be my opposite side, this will be my adjacent, obviously adjacent just being another word for next to, and my longest side is always my hypotenuse, which will be opposite the 90-degree triangle. So if this is my ratio, sine will be opposite over hypotenuse, cos will be adjacent over hypotenuse, and tan obviously my opposite over adjacent. So I'm not going to get into how to solve sides because you really should know that by now. Maybe in some examples you'll see how we'll solve sides later on, but just important to understand the basics of how my ratios work for now. Right. So also know that then if my angle is over here, beta, right, then this would be my opposite side, that would be my adjacent, and that will still remain my hypotenuse, right, because it's all dependent on where the angle is. That's how the ratios work. Okay, right, so getting into just what we basically do in grade 11, we know that often we'll be asked to simplify trigonometric expressions, right? So we're going to need to know all the tools in order to do that properly. First thing we're going to look at though is negative angles, right? So if we're dealing with negative angles, how does that work and how do we simplify that? So I'll say that sine of a negative angle, tan of a negative angle, and cos of a negative angle, right? So in the two above cases, whenever we see sine of a negative angle, we just know that that is negative sine of that angle. Tan of a negative angle will be negative tan of that angle. But cos of a negative angle, very important, know that that just becomes cos, positive of that angle. Reason being is because it has to do with when we do our cos diagram, which we'll touch on next in our next video when we do reduction formula, right? We know that that's 0, 90, 180, and 270, right? Ending at 360. So if we're moving negative, we see that we're in cos's quadrant. And cos obviously is positive over there, so that's why it will just be positive, whereas the other two angles are negative. We know then quadrant 1, all my ratios are positive, quadrant 2, sine is positive, quadrant 3, tan is positive, and quadrant 4, cos is positive. But like I said, we'll touch more on this cos diagram in our next video with reduction formula. Right, so that's how we deal with negative angles. Also quite important for simplifying is to understand what your identities are, right? So there are three identities that we really make use of. The first one being, we know that when we have tan of an angle, that can expand to sine over cos of that same angle. Same thing goes, for example, if it was tan squared theta, that'll just be sine squared theta over cos squared theta, right? So it's very important that to know whatever the angle is, it can expand to that as long as we keep the same sort of angle and sine that goes along with it, right? And my second identity is that sine squared theta plus cos squared theta equals to 1. Obviously, having its expansions of its own, if we follow normal algebraic rules, right, equations, that can also mean that sine squared theta will just be equal to 1 minus cos squared theta, and that cos squared theta also will be equal to 1 minus sine squared theta. Right. So very important to know these identities because you will be using this, especially when we are simplifying. Lastly, I'm just going to touch on special angles, and then we'll be set and ready to go and solve any trig they throw our way. Right, special angles, very important. These angles, special angles, will help us be able to solve certain trig ratios or certain trig ratios without a calculator, because we'll just be able to use these triangles. So my one triangle is an isosceles triangle with both angles being 45 degrees. My other triangle will look like that, with the one angle being 60 degrees and the other one being 30 degrees. So my special angles are 30 degrees, 45 degrees, and 60 degrees. So I know most of you use your calculators anyway. Please don't. Try and use your triangles to find those sides as ratios. So basically, we need to know in my first triangle with 45 and 45, my sides are 1 and 1, hypotenuse root 2. The 30 degrees goes with the root 3, 60 degrees, the smaller side, will go with 1. Hypotenuse will be 2. Right, so for example, if I ask you what is sine 30 degrees, right, you're going to say 30 degrees, I know sine is opposite over hypotenuse, so opposite is 1 over hypotenuse is 2. So it's a half. So I will say, just by the way, you can get away with a lot, so using your calculator. You can get away with the 30 and the 60 using your calculator because it will still be fine. But if you use your calculator when there is a root in the denominator, your calculator will rationalize that exponent and they will know you're using your calculator. So, especially when you do something like maybe sine 45, we know 45 is going to be opposite over hypotenuse, so that's 1 over root 2. But on your calculator, it will probably say root 2 over 2 because it will rationalize, right? So know that anytime you use sine or cos of 45 degrees, or if you use tan of opposite over adjacent 30 degrees, rather use your calculators for these ones, right? Because otherwise your calculator will rationalize it. Just a fun tip. Otherwise, don't be lazy. Just use the triangles all the time, right? So you'll see I'll use this in a reduction formula as well, which is the next video. But other than that, these are the basics and fundamentals you need to just slay trig.